So just like the video talks about Newton's third law, for every action there is an equal and opposite reaction, we're going to demonstrate how this rocket car can also be applied to that. Notice when the air comes out of the straw, it propels the rocket forward in the opposite direction. This is the same as when an actual rocket burns fuel and bursts out of its nozzle, allowing it to maneuver and turn in the vacuum of space. Hence Newton's third law, for every action there is an equal and opposite reaction. When you put air into the balloon, that is the same as your fuel making your rocket accelerate. So the more air, the bigger the reaction. To further demonstrate Newton's third law, we are now going to transition into a simulation game to help further your understanding. The website to access the simulation is phet.colorado.edu that you see on the screen. Once you are at the website, go to simulation at the very top of the website and scroll down to physics. Then find the simulation game, forces and motion. Once the game has loaded, you will click on net force to begin.
So in our right hand corner, we're going to check the values box. And then we're going to come down here to our blue people, and the little one is 50 newtons. And the other little one is also 50 newtons to the left. And then the medium blue person is 100 newtons to the left. And then we have our big person, which is 150 newtons to the left, which also applies to our right side with our red people. So again, the little person is 50 newtons to the right, as well as the other little one is 50 newtons to the right. And our medium person is 100 newtons to the right. And our big person is also 150 newtons to the right. So our goal is to find the sum of forces when two forces are pulling on an object. Also, we want to know the total and which direction it's going in. So I'm going to demonstrate a couple of examples for you. So just make sure that before we get started that you press the values box in the right hand corner so that you're able to see the numbers as we go through this example. This question is, if I had 100 newtons pulling from the left and 50 newtons pulling from the right, what is the sum of forces and in which direction? So as you see, our left is 100 newtons to the left and 50 newtons to the right. So we're going to subtract 100 newtons from the left and from the 50 newtons to the right. And then you see that blue wins, and we have the sum of forces, which is 50 newtons to the left because the 100 newtons is the greater force. Make sure you click the orange button so we clear everything off. So what we're going to do now for the last example is that we're going to take 150 newtons to the left, and we're going to take 250 newtons on the right, and we're going to press go. And we see that red wins because when we subtracted 250 newtons from 150 newtons, it is 100 newtons, and it goes to the right. Now we're going to transition into doing a worksheet over what we have learned. You will still use the simulation to complete the worksheet. Click the link in the description box labeled All About Newton's Worksheet and complete each question. You will use the simulation to help you complete each question and to check your answers after completion. Once you have completed and checked your answers, you can then click on the link in the description box labeled All About Newton's Answers.
So now we're going to go ahead and go over our answers from All About Newton's worksheet. Question number 1. A 150 Newton force pulls from the left while a 50 Newton force pulls from the right. What is the resulting sum of forces, or newtons, and direction being pulled? So just like our simulation, the 150 Newton force that's pulling from the left minus our 50 Newton force that's pulling from the right is going to be 100 newtons. And since our force that is pulling on the left side is greater than our force that's pulling from the right side, the correct answer is going to be to the left. Question number 2. A 50 Newton force pulls from the left while a 200 Newton force pulls from the right. What is the resulting sum of forces, or newtons, and direction being pulled? The correct answer is letter choice number D, 150 Newton force to the right. So since our Newton force on the left is 50 newtons, it's going to be subtracted from the 200 Newton force that's being pulled on the right, which is going to give us 150 newtons. And since our force on the right is greater than our force on the left, the force on the right is going to be greater. And our last question, question number 3, a 50 Newton force pulls from the left while a 50 Newton force also pulls from the right. What is the resulting sum of forces, or newtons, and direction being pulled? So again, 50 Newton force on the left and 50 Newton force on the right. So 50 subtracted from 50 is going to be 0. So you're going to have 0 Newton force with no direction. Letter choice, answer number D. Now that you've completed your worksheet and double-checked your answers, you will then click the link in the description box labeled Exit Ticket. The exit ticket will read, question number 1, a rocket burns fuel and bursts out of a nozzle, allowing it to maneuver and turn in the vacuum of space. Which of Newton's laws of motion explains how this maneuvering is able to occur? Option number A, an object in motion stays in motion unless an outside force acts on it. Option number B, for every action there is an equal and opposite reaction. Option number C, fast-moving air has low pressure. Or option number D, an object at rest stays at rest unless an outside force acts on it. Question number 2, a 40 Newton force pulls on an object from the left and a 25 Newton force pulls on the same object from the right. What is the resulting force and direction of the object? Option number A, 65 Newton to the right. Option number B, 15 Newton to the right. Option number C, 65 Newton to the left. And option number D, 15 Newtons to the left. You will complete the exit ticket and upload it online into your assignment box for a grade. This is to assure your understanding of the materials learned.
I hope you all enjoyed this lesson and had a fun time using the simulations to do some fun learning.